Greetings and welcome to all of you. I hope that this fall does not find you too terribly wet, swimming or canoeing around your house or something like that, because it has been a wet summer. Well, um, I hope that you are in this class, MT155 Introduction to Solid Modeling at MVCC. And I'm just playing around here with a model of something that I was working on for a company earlier this year. And this kind of stuff is not out of the realm of what you might be able to do when you are in this class. Well, but obviously we're not going to start here. But the again, make sure that you're in the right class here. Now, this class is usually taken by CAD students, mechanical engineering technology students, uh, pretty much those two. And most of you are probably in mechanical tech, but if you're not, that's fine. If you were just taking this for fun, good, cool. I'm here, and my name is Jeff. I'm an associate professor here. You don't have to call me professor or anything like that. Just don't call me by my last name. So, but you can call me Jeff. You can call me professor. You can call me Mr. Burt. I'm all good with that. Um, just a little bit of back about my background is I started using. Um, I graduated with a mechanical engineering degree in 1992, and about the only job I could get was doing some CAD work. I didn't even know CAD. I just took drafting courses, and so was basically paid $10 an hour to learn CAD. And in '95, I had some really cool jobs in there, designing artificial joints and so on. 95, I moved here and got my first taste of 3D parametric CAD. Now, I'd actually programmed a little bit of something like that in the previous job, but I got my first taste there of Pro Engineer, which is now called Creo. And I used that for a number of years until I came to the college. And I started a couple of classes like that, but it never really stuck. Actually, Creo or Pro Engineer lost market share to SolidWorks. And a few years later, we started a SolidWorks course. Eventually, I got involved, and I've been teaching this for many years since. So I've also I worked at ConMed, designing surgical tools, and I've done some work for some other local businesses. And so I like doing both. I like doing and I like teaching a lot. So I just want to let you know that I get that this is difficult. We're trying to do this within the structures of a pandemic that's going from one phase to the next, and we might have to go. You just never know if we're gonna have to go all remote or whatever. I understand it's been tough. It's been tough on me too, but it's got to be really hard for students. So I've got two students in my house, and they know what it's like too. So actually, I got a total of four that are students and been trying to do this whole remote thing for a while. But I'm willing to work with you. That's the thing, is that if you're willing to put in the effort, however, whatever form that takes, I'm willing to work with you as best I can to do what I can. To help you through this. But it's about learning. One way or the other, it's about learning. And we're learning a lot of different things, not just CAD, but about projects and attention to detail and design intent, stuff like that. I'll go into that a little bit more. Okay, so I wanted to shift gears here a little bit and let you know that, first off, you might, believe it or not, you might actually be in the correct course. And I'll show you what I mean here. So let's switch over to this. All right. Now, this is a little whiteboard that I have set up so that we can look at what MVCC offers in terms of our uh, mechanical related programs. I'm a mechanical engineer, and most people that I deal with are in some form, even the remote piloted program, that's kind of mechanical as well. So just really general like that. The certificates that we have are 1 year, whereas the rest of these are 2 year, 2 year, and 2 year. Okay, so a certificate is there pretty much you get some skills and then you graduate with a 1-year certificate and you go out and hopefully you get a job. Now, I can't promise anything, of course. No one knows the future and maybe you don't interview well. I don't know but you should have some skills that should qualify you for a job there. Okay, now we have a bunch of AOS programs that are very interesting. A certificate, oh, just going back there, it's like welding, we got machining, we got a couple others. There's a CAD certificate still running around. And the AOS is usually built off the certificate. Now you add a little bit of math, maybe some English or a couple other additional courses in there, and you get a 2-year degree. Now, AOS is Associates in Occupational Studies. So occupational, yep, tells you that you can go out there and get a job, but also you might be able to have some upward mobility. Okay, so um, so because you've got that 2-year degree, you can see a longer project through. You can do more things. You've got a little bit more skills in other areas of life. So you know so here we have some of the similar kinds of things. Um, you've got CAD and welding and maybe machining. We got HVAC in here as well. Big demand for all of these. So we, you know, that's kind of what's going on in this spot. Now we're going to move over to the AAS. AAS is Associates in and it's blanking on me right now. Associate in Applied Sciences. That's what it is. So that means that it's the courses are less focused on a particular thing and a little bit more general. And so you have a little bit more general skills. So in this case, it's mechanical engineering technology, civil engineering technology, electrical engineering technology. So these are engineering technology. So when you start using the word engineering, there's going to be some more math involved. And so that's kind of part of the story here is that if you want to look at the math involved, there's um, a, a little here, and then there's a there's very little there. There might be a little bit more here. Well, here you get a lot more. Okay, a lot more math going on, and then the AS, well, that's like crazy through the roof kind of stuff. All right, so but these, where do you go with from here? So these you can do now one of two things. It's most flexible. Most of you again are probably METs. You can graduate after 2 years, you know, and you can get a job. All right. A lot of my students do this, but then also a lot of my students go on and transfer to a 4-year school. Okay. And the 4-year schools that usually my students go to are SUNY Poly, RIT. I got a couple of RIT right now, and Buffalo State. That's different than SUNY Buffalo. But I wanted to point out to you that RIT here is a great place. It's one of the best places for engineering techs to go. They've got incredible capabilities, all the sorts of labs, all sorts of recruiters come on campus from the best companies. So if you wanted to work at Ford, you might want to go to RIT because they actually recruit from there. Okay, they don't recruit from SUNY Poly. All right, that's just not where they go. So, but RIT had now is it more expensive? Well, on the face of it, yeah, but you'll probably get a lot of financial aid. Okay, there's a lot of that's the rich people price. We don't worry about that. There's a lot of financial aid available, and especially if you're going to MVCC for 2 years, that's already the smart, cheap choice. RIT loves our transfer students. So anyway, that's kind of where you can go with that AAS. And my students who get jobs, then don't go on for their 4-year, at least not initially. They're doing great. They're usually loving their jobs. They're getting paid well and benefits, the whole shebang. It's really good. Okay. So let's see. last but not least is the AS program. Now, listen carefully. If you were looking to become a mechanical engineer, civil engineer, electrical engineer, nuclear engineer, something like that, and they pointed you at our engineering technology program, then that may not have been the right one for you. Okay, if you did really well in high school and say you took calc or pre-calculus or something like that, and you're over here in mechanical engineering tech, you should really be over here in the engineering science program. Okay, not saying you have to, but it's probably where you were shooting for. Now, our engineering science program is really heavy on the math, heavy on the sciences. But what do you do with that? You usually, almost always, transfer to a 4-year school. That 4-year school will be Clarkson, University of Buffalo, Binghamton, RPI. Very good schools, but again, this is from engineering science. If you wanted, because they go through calc 1, 2, 3, and differential equations, that's all sorts of heavy duty math that you're not getting over here. And so therefore, you wouldn't transfer to the 4-year school as as a junior. You have to start all over pretty much. Probably best to start all over as an engineering science right here at MV. So yeah, you'd spend some more time. Now, if that's your goal, is to be an engineer like that, go to SUNY Buffalo or Clarkson or something like that, but your math skills aren't all that great, oh yeah, right here is where you should be. Get your math skills up, maybe stay a year, get some other good skills, and then go over to engineering science, transfer right over. That happens all the time. Okay, that's very common for that to happen. We totally work with you on that. So anyway, I've got a lot of students that I also teach one course in the engineering science side of things, and I've got a lot of students that have graduated from there, and they go on and do great things. A few are in their PhD programs and stuff like that. So this is MVCC is a great place to start, no matter where you are, and you can even move from one to the next to the next to the next. Seeing it happen. Not terribly common, but if you've got the chops, especially for the math, make it happen. Okay, so that's just kind of like the roadmap of what MVCC has. I want to make sure you know that you're in the right spot, because sometimes the advisors that you run into, they might not have placed you properly. So I want to take care. If this is if you're not in the right spot, then let me know immediately, and we'll try to work it out, get you a new schedule, get you a new program and all that stuff. Happened last year. Got one student who was like, yeah, I finished calc and I did really well and I'm in the wrong program. And he got into engineering science and he's loving it. So he's in his second year now. But it was totally worth it to go through it for that one student who would have wasted so much time. Okay. All right. So also tell your friends. We got all these great programs going on, and jobs that come out of them are all great. I mean, I'm not just selling you stuff. My students do not generally end up as baristas at you know, wherever, to Starbucks. They usually are out there in the industry doing good work, doing great things. I got a student called me up the other day. He's got a patent. So, hey, that reminds me. Also check out my video, uh, which is just about a 20-minute video about my teaching philosophy and stuff like that. It's in a link somewhere, but I'll probably on Blackboard. I'll show it to you. But if you want to know more about me, what makes me tick, you're going to have me for a few classes. So hopefully that'll work out. Okay. So let's see. So if you want to learn more about some of these, you can just go over here to the college catalog. So here's civil engineering technology. Let's go down to, no, I don't want to use Chrome right now. Let's go down to mechanical engineering technology. Like I said, this is where most of you are going to be. Dun, dun, dun. Okay. So here's the associate implied science degree. There we go. And This is where you can find all that information, 197 of 228. All you got to do is follow that particular spot. And this is basically your roadmap where you're what you're going to be going through. And this is this course right here. All right. Okay. So if you have any questions about that, I'm probably your advisor to either myself or Nate Roskup. And it doesn't matter if you've got Nate as an advisor and you feel more comfortable with me or vice versa, or he's not available or I'm not available, you can talk to one of us. Okay. We're not like, territorial or anything like that. So, and Nate and I work together pretty well. Okay. So next on the list is the syllabus. Okay. So we're going to park here for a bit. And I just rearranged the top up here a little bit. I don't really like it, but that's how it is because I got a billion ways of contacting me. So I said, call me if you need anything. Well, here we go. So make sure you spell my name right. And especially if you're sending me an email, because if you don't spell my name right, you won't get to me. But there's my email address. So that's a great way of contacting me because we've got that'll keep a record of everything. But it might not be the fastest way. So if you have a real quick question on how to do something in a video, or you need to know what 2 + 2 is, or what your next move is in terms of taking a class or something, maybe that's not the best one. This is a great way of getting in touch with me. Discord. Okay, I've got Discord on my phone. I've got Discord on my computer. It comes up. It gives me a beep, and we can exchange pictures and that drawings and links and all that kind of stuff really fast on Discord. So that's why I like it a lot. Whereas email, it's a little bit clunkier. All right. Some students, I give you, here's my personal number here, but it's not as easy to work with as Discord. All right. If you really need to get a hold of me for some real emergency or something like that, go this way. I don't mind texts in general, but often it's like, hey, what do I do about this? And it really takes some kind of like picture. Maybe you're working on homework, something like that. Just use the Discord. It'll be easier for everybody, because I can do a lot more with that instead of on my tiny little phone screen. All right, so let me show you Discord for that matter. Okay, so I even set up a whole channel for you folks, but here's my handle, Coach B hashtag 0388, because that's really amazing, I guess. But I'm, let me know what your handles are or whatever, and I'll invite you. Some of you might already be on it, but just let me know. And let's see, what's this one? Where did I put that one? Oh, here it is. All right, and so it's going to put it with some of my other classes. These are some of my other classes that I have that for. And that's about that. So that's Discord. Let's connect up. We can even do video chats on this, although I prefer Zoom. Speaking of Zoom, this is my Zoom office hour web link here, right here. And just click on that and it'll take you to my office hour. But I'm not always on it. But if there's something that you need to show me, like on your computer, and you need to show something, it's really easy to just click on that, set up a Zoom, that kind of thing, as long as we're both available at the same time. And I try to make myself as available as possible. So that comes to this point, office hours. Okay, by and large, during class, I'll stay a little bit late on class, except on the Friday class. I'll stay just a couple minutes because I've got to get ready for another class that's remote. Yeah, don't ask me why. Just it's all complicated. But especially for those Friday folks, you got to keep in touch with me throughout the week. But I will be. I'm generally available in the evenings. I am not a morning person in general, but if that's the only time you've got, I'll try to work with you. But I'm usually up pretty late. And so just send me a quick thing on Discord. Hopefully I'll be there. I probably will. And or else I'll say, hey, let's set up a time tonight or tomorrow, whatever. That's a lot better than just standard office hours. Okay. Some people say, oh, do you have office hours? I'm like, yeah, but what's good for you? Because often my office hour that I'd prefer is when you're working. Always happens that way. So let me know what you think about that. Okay. Here's my office phone number, but I'm basically never there. So if you want to leave a message there, that's fine. But I suggest these other methods that'll take a lot less time and be much more efficient. And this is where my office actually is, but I'm never there. So if I do hold office hours on campus, it'll almost certainly be in the classroom I was just in, or something like that. Um, I don't really need to use my office all that much. Okay, but if you say, "Hey, are you on campus?" Whether it's text or Discord, sure, yeah, I'm in such and such a room, blah blah blah. I'll try to make things a little bit more consistent throughout the semester as we figure out everybody's schedule. But for now, just say, "Hey, are you available?" That's the best way to find out when my office hours are. And the chances are I will be, or I will be soon. One of those two things. Okay. All right. Um, Moving on through. You can read this, but solid modeling. This is not an art class, so I'm not going to ask you to strike a pose for modeling or something like that. This is a CAD, a type of computer-aided design that is 3D modeling, and it's parametric. So it's very different than just like 2D drafting, like with AutoCAD or something like that. So it's very different and requires a lot more thought ahead of time, a lot more design intent. So I think here it is. Model planning and design intent are stressed. So, hey, it's great that you may have had some experience with this in the past. I'm glad, that does help you, but it can also hurt you because you may have developed bad habits. So, um, we're gonna get there, but just watch out for that because if you think you know what you need to know for the class, then that's a problem. If you're ready to start over and learn why you should do one thing instead of another, then you're in much better shape. Okay, so what are we going to do? We're going to sketch cross sections, duh. Okay, but there's going to be reasons. We're going to set that up. The sections are really not complicated, but they require the most thought to think through, and also sometimes they're the most annoying because the computer has all these little glitchy rules. It's better now, but it still is weird. So we're going to talk about cross sections a lot. We're going to create 3D features, of course: protrusions, cuts, rounds, blends, revolves, and sweeps, and maybe a few others. It's going to be fun. You're going to really be surprised at how far you come if you do things my way. If you just insist on doing your way, then you're not going to get very far. Okay, plan solid modeling to capture design intent and parametric capabilities. Did you know that we can use um, one number to define another number? We can even use formulas to do it. But you may not have known that. So I can say one side is going to be 1/3 than the other side. That's parametric. That's using um, one thing to define another with formulas involved. And then we're going to create drawings. So we've got sketches that develop into model or parts that develop into assemblies, and assemblies and parts that can make drawings. And drawings are um, very easy to start and very difficult to finish. So you'll see what I mean by that. Okay. And then we're going to do spreadsheets. So if you've ever used a spreadsheet before, you're in great shape. I just hit the basics. If you've never done a spreadsheet before, hopefully you will learn how powerful and wonderful they are. Um, so I go into more of the details here on the major course topics: 3D thinking, relations, drawings, what's overdefined, fillets, chamfers, helices, lofts, spreadsheets emphasizing formulas and design tables, assemblies. We got insert, mate, subassemblies, pattern assembly, um, and even we're going to do even some cool motion stuff. Okay, so what do you need? All right, starting off with 6-inch calipers. Forgot to bring those out. I think these are my 8-inch ones. No, these are my 6-inch. Okay, 6-inch calipers like this. Okay, do they need to be dial calipers like this? No. Most of the ones that are out there now are digital, and unfortunately for digital, guess what? They run out of batteries. This guy, not so much. Now, do you need to have expensive? No, please don't get expensive. these are a really nice set. That's why I don't bring them to school. Um, but you know, there are some out there that are like $20, and you should any mechanically oriented person at all. I don't care if you're in CAD or UAS or mechanical tech. You should have your own set of calipers. So go out and get them. Okay. I think I've got some. Yeah, I've got these ones Harbor Freight. Um, they just go out and order them because you're going to need them probably for your manufacturing processes class as well, but you're going to need them for the end of semester project. Considering you don't have any books that are required for this course, that should not be a problem. Okay, now you should have, could you get along with just the school computers? Yes, but that's only if you basically live and breathe in the classrooms. So it's probably best that you do have a good computer to load up SolidWorks on. Otherwise, you will not have the time in class. You definitely do not have time. I'll guarantee you don't have enough time in class to get all the work done. Okay. So either you're going to have to live in the lab, not usually recommended by the college, uh, or you'll need a computer. So most people do have a computer. We even have computers available on campus for you to borrow. You have to sign them out and return them. Uh, but a lot of people are saying, okay, I've got money for a computer. What should I get? Well, here you go. It's got to be Windows. It's got to be able to run Windows. If you have a Mac and you know how to make your Mac run Windows, good for you. I don't. I tried once, failed miserably. My kid can do it, but I can't. And even then, he says that my old computer runs SolidWorks faster than his wicked blazing fast Mac can, because the Mac has to do a bunch of gyrations to make it work. So I strongly recommend a PC with has to have Windows 10 on it. It's got to be 64-bit, but that shouldn't be an issue anymore. And it should have an Intel i7 or i9. You don't need an i9 at all, really. i7 is just fine. An i5 will work, probably, but no Chromebook. Will not work on a Chromebook, and it will not work on something with 4 GB. Just won't. It will not even install. Okay, it's not even going to go slowly. 8 GB, it should work, and that's for RAM. It should work, but it might go kind of on the slow side. And 16 gigs should be just fine. Okay, some have 12. That should work too. Okay, if you have a dedicated video graphics card, try to. Okay, I've got a laptop over here. It's got a dedicated video driver card, and everything seems to work just fine with that. Does it need it? No, but you'd be surprised at how cheap some computers are that will actually run SolidWorks. But I wouldn't push it. So don't buy the cheapest thing. That's another general. And don't buy it from Walmart. They have garbage parts inside those computers. Okay, but do get a major brand in general. It's usually a good idea. If you want to build your own, you know what you're doing, fine, fine. Go build your own. But don't buy a Mac. Don't buy a Chromebook. That kind of thing. All right. Internet audio and video communication capabilities, so that we can do this here, so that we can chat online, so that we can do Zoom, so that we can do all those kinds of things. That and if you live out in the middle of nowhere that has no internet, you're going to be in trouble. But if you can find a spot, if you can make a way to be on campus a lot, then and get your stuff done, then that's fine. But you're going to have to, set aside several hours a week to get the work done. Okay. Is there a book? Yes, there is a book. I don't use it, but I have some students who say, "Hey, I really like books." I'm like, "Oh, okay. You can use this book, but you still have to do the other stuff that I have for you. That's not in a book." All right. So, but this might be extra stuff that you might want, but most students don't have time to do extra stuff. So, but this is extra. Okay. So here's my basic grading scheme. And by and large, if you keep up with everything, you're going to be right up here. Okay. If you slack off, that's where you start going down, and you go down real fast. So you do not want to slack off. There is no time, because you might think, oh, it's an easy class. Initially, it is. I start you with some baby steps, and then we get to the next project and stuff like that. And then it's like, whoa, I'm behind. It's like, yeah, you are. Well, what can I do to catch up? Well, put a whole lot more hours in and keep in touch with me and stuff like that. There is no magic bullet. Okay, so here's our basic schedule. So I've got a survey, a math quiz, and a Blackboard reading and quiz, all due by the first week. Okay, these are very easy. Should take you not too long, and we're going to go through the math quiz eventually. Um, but uh, but that stuff's on Blackboard. All right. Once we're done with that first week of introductions and getting everybody situated, and reviewing some of the math that maybe you've forgotten, um, a survey that I need to see where we're starting, a Blackboard, so you understand what design intent is and all the other stuff that needs to be set up ahead of time. Then we dive into the solid modeling of the SAW project, which is due only 2 weeks later. Okay. It's a fairly simple project. You just follow my steps and you'll be in good shape, but you got to get on it. Okay. You can't slack off. You might have to work weekends. Sorry to tell you that, but there you go. Screwdriver. This one is the one that people get most hung up on. It's a lot more involved. There's a lot more parts, and it's much more challenging, and that's why it's worth more of the grade. But you do have 4 weeks to do it. Okay, but it could be done in a weekend. It seriously could, or at least the majority of it could be done in a weekend, and then all the little bits and pieces for the next week. But you got to actually do it. And if you don't stay on top of this, it's gonna come back. And you do get dinged for turning in late assignments. So if you can turn it in early, see, even if you turn it on time, guess what? It's probably not right. And we go back and forth until it's right. This isn't like, oh, I'm just gonna turn it in and see what I get. You have to keep going back and forth until it's right, because that's what really happens in industry. You don't design something up, or do a CAD file and then hand it on to the next guy so that they can fix it. No, they're going to send it back to you until it's done right. I Trust me, I've had it done to me. I was, like I said, I was a CAD jockey, and I had um, uh, Wally the checker come and talk to me all the time and say, you got to change this. Sometimes he would change things that he'd changed the previous week back to what I had before. Like, what? So, but but that's the way things actually are. And I'll be able to explain to you why I do those things. But guess what? There's a lot of guidance to help you through that. A lot without me. Okay. So anyway, so that's the next bit. Okay, project proposal. Um, So once that's done, we start getting teams together to do a common project where the two of you uh, make a bunch of parts, and then you assemble them and make drawings and stuff like that. That's the final project worth a good chunk of the grade down there, 25%. And what it is you just take something from home, like a tool or a kitchen implement or a toy, something like that, and you take it apart and you measure all the parts, and then you put it back to and then you model it up using those dimensions in SolidWorks, and then you assemble it, and all that stuff in SolidWorks. It's I'll show you some examples, don't worry about that, but it'll be you'll it's a great process, and it's actually something we do in industry all the time. All right, so uh, that's about the middle of the semester. You should be thinking about that right now. What kind of things do I want to take apart that aren't too terribly complicated, that we could be able to do? So the last major project, if you will, is the crescent wrench, and it's you effectively have 2 weeks to do that. And then the tool assembly and storage board are also part of level 3, and those are due the following week. All right, so then in November, we start talking about design tables and spreadsheets. And there's another mug project if you want to do that. If you have time, you can do that. Um, but then there's the major project and presentation that is due in the middle of December. So you should have some time to do all that measuring and developing and all that stuff. But the project has to do all of the things that we start off with. We have to have design intent, spreadsheets, a variety of different tools that you use, and drawings, assemblies, all that kind of stuff. So but I lay it out in a rubric, showing you what to do. But it's going to be a project unique to you, and so you're going to have to actually do it. I just give you the steps that you need to go through. Okay, so I've already covered most of this, but the assignments are given on the Blackboard system and through Google Docs. I got a lot of great guidance through using Google Docs. So consult Blackboard to find out what's next and usually the Google Docs to find out what's expected. But I also have a lot of videos to show you too. It's self-directed. You don't come to class and figure out what's next. You go to Blackboard and figure out what's next. Okay, and you can work as far ahead as you like, but as you finish the projects, I don't want you it's okay to start moving on, but you're not done until you've made all the corrections, okay? So there's a lot of videos online, guidance documents to complete most of it, all right? Please consult those before asking questions, because if you send me something and I'm busy and you're just sitting there waiting, chances are the answer to your question is in that document. I've had these questions, I've been doing these videos a long time, so I've tried to put as many of those answers in that document so that students can keep moving faster. Okay, so that you're not stuck. I've been a student and I've been stuck before. I don't like that feeling. That's why I put that all there. Okay, so once you've completed all the tasks for a project, and that includes the Blackboard, YouTube videos, and the guidance, and you've asked any additional questions, and you're confident your work is of the highest quality, okay? None of the slacking stuff. Put it into we're gonna have a shared Google folder, but also in class, we might be able to go over it as well. So make sure you read this, okay? But I also have guidance on how to submit stuff, so that'll be good. And it is your responsibility to make sure that your technology, access, schedule, and all that stuff are adequate for timely completion of the assignments. I cannot debug your computer. I'm sorry. I wish I could, but everybody's different, and I help whenever I can. Once in a while, say, "Oh yeah, I ran into that problem. Do this. Maybe that'll work." But it's going to really be up to you, and I'll send you to IT if that's what it takes. But it's up to you to do that as soon as possible before classes start. Okay. So every year, unfortunately, I have students who think that they are smarter than I am. I'm not like the smartest guy in the room, but hello, I've been doing this for probably more years than you've even known the words computer-aided design. So I've seen cheating. I know what it looks like. So if you think you can pull one over on me, then you might want to choose a different course. Okay, so don't do that. If you need help, ask. If you're running into trouble, ask. Don't think that you can, because that makes you go a different path completely than help. Okay, that's not the path you want to go on. Okay, so make sure you look at that. I have a system that checks for original work, and everything that you do leaves fingerprints all over the place, and it's going to be a whole lot harder for you to figure out how to undo that, to change the fingerprints of somebody else, than it is for you just to learn what you're supposed to learn, just to do the project. So just do the project and learn, and don't risk your college career and sometimes your your further career by becoming, going into cheat mode. All right. Okay, if you do have any disabilities, I've been able to work with all sorts of students from all different walks that have all sorts of different disabilities. I'm willing to work with you. And if you need additional help, we can work with the I can't remember, Office of Accessibility Resources. Okay. Um, and there's their contact info. Also, we may have some discussion times in class. You might run into other people, that kind of stuff. I expect you to be civil. Usually I don't have to say that, but I'm going to say it anyway. I've had a couple issues in class over the many years, but usually people are perfectly fine. We're all in this together, even if we disagree on how to go about things, but we are together. We're part of a team. So let's work together as a team, help each other out, and be civil about it. And if you think that some people in class don't belong there, that they're less of a person because of how they were born or how they dress, then you can leave, because that would make you the lesser of the people. So just uh, be civil, do not discriminate. Remember that we have a lot to learn from each other. And again, as a team, we're going to make it. Okay. So let's see. Think I've emphasized Discord enough. Make sure you get in on that. Um, let's see. Next is Blackboard. Okay, so this is what your Blackboard is going to look like. Have I got that? Okay. Learning. I think it goes straight here. Maybe it's got start here. Here we go. I might modify this a little bit, tweak it a little bit here and there. But where you really want to go here is, of course, um, read the quick introduction here, and this is really where you're going to park most of the time. All right, and this is the calendar. I'm going to set up that calendar. Introduction. I've done a lot of work already here. Introduction. So day 0. This should be the link to this particular video. Obviously I'm recording it now, so I'll have to update that. But then go to first steps, and Friday students, even if you're not a Friday student, I really want you to set up a first week office hour with me so that we can talk one-on-one about who you are, and get to know you. Can get to know me, I can get to know you, and all that stuff. Here's a Blackboard introduction, but still watch that day 1 video up there. And then there's the computer skills survey and a basic math quiz. Make sure you take this basic math quiz. So you just click there, click on begin, and remember it's timed. And so this is what it's going to look like. It's going to ask you definitions, a little bit of math here, nothing crazy. And I would greatly appreciate it. I'm not going to require you. It's not a math class where this is absolutely critical, but some of these, like, okay, the decimal closest to the value of the fraction 3/8. All right. Here's what I want you to. I want you to try the first time around. Just try it yourself in your head. Don't use a calculator. Okay. Um, because sometimes that kind of knowledge is important to just kind of have in your head, and see how close you can get with the guesses. You can, yeah, it's timed, but you can do this again if you want to. We have multiple attempts allowed. I can't remember. I think like eight attempts, so you can try it several times, and get better at it. All right. So passing is, like, I think I said 70 or something like that. So leave that. Okay. So that's introduction. So coming back through this, so then CAD preparation. This is all about CAD, and go through these kinds of things. Um, this whole list of things, but again, they're relatively short reading. Um, Basically, how to set up a network drive folder and junk like that, and make sure you save often and do not depend on thumb drive memory. I think I have this emphasized here for a reason. Okay, so this is where you're going to park most of the time. Then there's your level 1 project. And when you want to start the level 1 project, first read this as always. But again, do not try to do the project in your style. Do not. If you think you're the smartest person in the room, hey, that's great. Okay, if you know your CAD stuff and you want to say, no, Professor Burt, I'm going to do it my way, then I got two questions for it. A, what are you doing in this class if you already know everything? B, fine, do it your way, but only after you do it my way. Okay. And when you do that and you do it your way, if you want extra credit, defend why your way is better than my way. I'm listening. I'm listening. But I am prepared to defend why my way is better than yours. Once in a while, I do find a new way. Our student shows me, say, hey, there's a new thing that goes on here. Great. Extra credit. No problem. But first, do it my way. So here's what you do. You click on Saw Rivet. So this is the first one. Okay, so here's the guidance documentation. Okay, I show you a bunch of different little bits and pieces where students often get hung up or whatever. So make sure you use a file name and so on and so forth. Um, and you read through this every step. Now, the this first video, just watch it. You'll just get an overview of what's going on. Okay. The second video, this is what you really want to follow. So you right click on it, um, open link, or else you can just left click on it, click there. It'll come up with this link, and then you'll hear my lovely voice like I'm hearing it right now. It's great. But I show you step by step how to go through. There we go. And notice I'll, of course, have these things. So then I show you how to do a sketch. And some people think I'm slow, but some people think I'm slow, and that's true, but that's because I've got introductory students. If you choose to fast forward and stuff like that, heaven help you, because I do very specific things and you're probably going to skip over a very important little detail and it'll mess you up. You'll spend hours trying to figure out what you did wrong. Meanwhile, that was all to save just a few minutes. Nah, just go go through carefully at 1x speed and you'll be in good shape. You're gonna save a lot more time by doing it carefully than you will by going hastily. All right, so that's how all of these things are. So this clicks and it opens up a new Google document and a couple of videos for you to watch and go through, and got extra one, some extra ones. But then notice how I have the section, avoid problems and make it easier. You want to make it easier? Go through these. There's not always a lot of them, a couple pages worth. And then here's my reference drawing. And then, a little checklist at the end. This also shows the feature tree that I have, and yours should look almost identical to that. All right, so I do a lot here to help you succeed. That's what I'm here for, to help you succeed. Okay, so that's most of Blackboard. Let's go back to start here. Now I have a couple of links here. So this is the office hours link. Also, I've got a TA that helps out, and his name is Keegan. He also happens to be my son. He's been helping me out with SolidWorks for a few years now, and so he's pretty familiar with everything. But he can get kind of busy. So if you need me, here I am. If you need Keegan, here he is. And so I've got all these, the grades, syllabus, and so on right here at your fingertips under Start Here. So that's Blackboard. Now, I want to go back, finish this up, and say that, yeah, I know this is tough. Learning sometimes, last year was a lot worse, actually, because it was all remote, all asynchronous. So I'll be able to see you all during the week, but especially the Friday crowd is going to have a rough time if they wait till Friday to get anything done, and if they only depend on Friday, because there's going to be a lot of work to catch up on. So you can't nobody can depend on just the time in class. There's definitely outside time. And I know it's tough, and that's why I make myself available. That's why all these resources are right here for you. And I've got the TA and so on. So we should be. You guys have all the resources you need to succeed. Let me know if you have any troubles, and I look forward to meeting you. Let's see. One last thing is I wanted to um, just go through a couple of quick bits here. So now what? Um, Try to download and install the software. Right now, that I think you should be able to do it, and it is going to be from last year. There's a glitch hanging out for this coming year, but we still should be able to do no problem using the 2020-2021 version. So try to download it and install it. If you have any questions, let me know. I have a whole bunch of, you don't have to say, well, what do I do? It's all on Blackboard. Okay, all those instructions, Blackboard and stuff like that, all that stuff's there. You don't have to go try to figure that out yourself. You don't have to buy a student version or anything like that. It's all right there. I've got a whole document to it. You know what? I thought I was supposed to. Let me see if I can. Yeah, I must have skipped over that. Yeah, I did. Okay, so I have a whole software, SolidWorks installed diagram. So you should be able to download it. I've got a link for you to download like this. And the problem is you can't download it from their website anymore. But I've got a download link for you. So you're going to have to find that on Blackboard. So I've got that on Blackboard. But then once you have this file, I've got it step by step going through here, and make sure you go on to the next page, which is right there. Okay. All right. So so make sure you you do that. So try the download and install on your PC. Um, get a Discord account and connect up with me. All right, sign up to have a Zoom conference with me before the first day of class and log into Blackboard. So all these things are, you might have to do one before the other and work through the introductions and CAD preparation. All right. So again, I look forward to meeting with you and meeting you in person. And I might have to have a mask on, but that's the nature of our crazy world. But I totally look forward to it, and I hope you do too. Have a great day.